Okay, so I am doing 2.52 right now. And it is the acceleration of a bus is given by, that looks like alpha t, where alpha equals 1.2 meters per second cubed. If the bus's velocity at time t equals 1.0 seconds is 5.0 meters per second, what is its velocity at time t equals 2? And then B, we'll get to B. Let me do A. So for A, like I said, it is asking us, I already forgot, what is the velocity at t equals 2? Okay, so we have the acceleration equation, right? And we know that acceleration is equal to the derivative of v. And then I'm just going to solve to get an equation to which I can find the velocity. So since this is a differential, you can split it up. And I am going to make it the integral from v naught to v dv equals 0 to t a dt, a being a constant. And this leads to v minus v naught equals 1.2, like I said, a constant, given to us in the problem, is equal to 0 to t dt. Okay, and then that yields v equals v naught plus 0.6 t squared, evaluated at t equals 1 second, and that gives us 5 meters per second. Awesome. And then let's see. So we have that, and now we can plug that in to get some more numbers that we can plug into a final equation to get the final answer. So I use our v naught equation. Well, I manipulate this to get v naught, and I have that v naught is equal to 5 minus 0.6 times 1, which equals 4.4 meters per second. Okay, and then I have that, therefore we can conclude that v at t equals 2 is equal to, and then we use this, 4.4 plus 6 times 2 squared, and that gives us an overall velocity of 6.8 meters per second. And that is it for part A. Now, I found that part B was kind of similar to part A, and part B is asking us if the bus's position at time equals 1 is 6.0 meters, what is its position at time equals 2? So, once again, we know, let's do it over here. Let me erase this. So, we know that velocity is the derivative of position. So, once again, we can split it up because it's a differential, integrate, and then get equations that we can use to find the ultimate position. So, we get that after doing the integral, we get the equation that x minus x naught is equal to the integral from 0 to 6 v naught dt plus 0 to 4.6 t squared dt. So 0.6 t squared dt. Alrighty. And then from there, we can get that x equals x naught plus v naught t plus 0.6 over 3 t cubed. Alrighty, so, and then I plug in that at time is 15. Sorry, that's wrong. That's 1 second. We get that x is equal to 6 meters. And then we use that and we plug it into an x naught equation. And we have that x naught is equal to 6 minus 4.4 times 1 minus 0.6 over 3 times 1. And that gives us 1.4 meters. And we're not done yet. So we plug that back in and we can conclude that x at 2 seconds is equal to 1.4 plus 4.4 times 2 plus 6.3, that's wrong, plus 0.6 over 3 times 2 cubed equals 11.8 meters. And that is the answer for part B. And then finally, we have part C, and that's just asking for the graphs, I believe. Let's see. Yep, so they want the graph of the A of y, v of y, and the x of t graph for the motion. So I have our x of t graph being from x to t, and then this is exponential. And then for our v of x of t graph, I have from 0 to 60 to 10. And this doesn't start at 0. And it goes like that. And that's all I have.